Hello everyone, let's start with the next topic, that is dimensional analysis. And in this context, the definition of dimensions. The dimensions of a physical quantity are the powers to which the fundamental units are raised in order to obtain the derived unit of that quantity. After that, we have some fundamental quantities with their dimensions. A specified letter in square brackets are actually given for a particular fundamental quantity, and which is known as its dimension. So mass, starting with mass, capital M is the dimension of mass, capital L is the dimension of length. Similarly, capital T is representing the dimension of time. For temperature, theta or K, some places we use theta and somewhere we use K. In electric current, it is A, capital A in square brackets. And luminous intensity, that is CD, in again square brackets. And the last is amount of substance, MOL in square brackets, that is the dimension of amount of substance. So here we have 7 fundamental quantities with their dimensions. On the basis of these fundamental quantities dimensions, we can also determine the dimensions of some derived quantities. So let's start with some derived quantities and to determine their dimensions. First is area. As we all know, the basic formula of area of a rectangle is L into B. L is actually representing the length and B is actually representing width. But in terms of dimensions, both have dimensions L and L, because everything is L, everything is length and it is measured in meter. So whatever is measured in meters, dimension will be L. So L into L means L square in square brackets, and it can be written as m raised to power 0 L square t raised to power 0 in square brackets. So this is the dimension of area. Next is volume. Dimensions of volume. First, the formula L into B into H. That is the formula of volume of a cuboid. L length, width and height. But all these three things measured in meters, so all have dimensions L, L and L. So it will be L cube, and it can be written as m raised to power 0 L cube t raised to power 0. After that, we have further quantities. Next is density. The formula of density is mass upon volume, and the dimensions, similarly the dimension of mass is m and the dimension of volume is L cube. So it will become m L raised to power minus 3. That is the formula of identity, m L raised to power minus 3, and it can be written as m L raised to power minus 3 t raised to power 0. After that, we have velocity. Formula of velocity, again very simple, displacement upon time, we know very well. Now the dimensions of velocity, displacement L, it is measured in meters, and time capital T. So the dimensions of velocity will be L t raised to power minus 1. So it can be written as m raised to power 0 L t raised to power minus 1. Next we have acceleration. Acceleration, formula of acceleration is change in velocity per unit time. So dimensions will be change in velocity, dimensions of change in velocity will be L t minus 1, and dimensions of time will be t. So it will become L t raised to power minus 2, and it can be written as m raised to power 0 L t raised to power minus 2. Another we have force. Formula of force is mass into acceleration. Dimensions can be written as dimension of mass is m and dimension of acceleration is lt minus 2. So the dimension of force will be m l t raised to power minus 2. So here we actually derived the dimensions of some derived quantities. We explained. Further quantities you have to do by your own. And thank you.